In this video we're continuing with vectors and we're going to look at the second of two videos on the dot product, sometimes known as the scalar product. Now we've seen this slide in the previous video, so remember the dot product can be thought of as directional multiplication, and multiplying two vectors means that we're applying the directional growth of one vector to another, and the result is how much stronger we have made the original vector. Now, we can look at the scalar product, denoted A dot B, as follows. We can look at the rectangular perspective, which we focused on in the previous video, and we can also look at the polar perspective, which is what we're going to focus on in this video. So, using the polar perspective, the dot product of A and B, vectors A and B rather, is equal to the magnitude of vector A multiplied by the magnitude of vector B multiplied by cos theta, where theta is the angle between the vectors A and B. So let's explore the polar perspective of the dot product a bit further. So let's firstly take two vectors, A and B. And let's rotate the coordinates so that the vectors show that B is horizontal. So everything is almost based on this new x-axis, if you like. Now the dot product hasn't changed. We've just tilted the diagram, so it's almost like turning your head and looking at the same thing, just in a different way. Okay. So vector B, we can now look at it in component form as the magnitude of B, 0, and vector A, we can say has new components A1 and A2. So previously we would have combined each component of A with each component of B. And we can do this as before, like so, and we'll get A1 multiplied by the magnitude of B plus A2 multiplied by 0, which is the y component of B. Now obviously that second one, the A2 multiplied by 0, will give us 0, and that's because we've got two vectors which are perpendicular to each other. Now this A1 here, what really is that? Well, what is that x component of A, assuming that B is actually the x-axis? Well, that is the magnitude of A cos theta, i.e. the projection. And this results in our dot product, A dot B, equaling the magnitude of A times the magnitude of B multiplied by cos theta, where theta is the angle between the vectors A and B. Now this definition of the polar perspective of the dot product or their scalar product is given in the exam, so you don't have to worry about remembering this. And we should also note that the diagram should look something like this. So the angle theta between the vectors assumes that the vectors are pointing away from the angle. So let's look at some examples now where we might be required to use the dot product or the scalar product. So example 1, vectors A and B have magnitudes 7 and 3 units respectively and are at an angle of 60 degrees to each other as shown. What is the value of A dot B? So our solution then, we know that A dot B is equal to the magnitude of A multiplied by the magnitude of B multiplied by the cosine of the angle between the vectors A and B. Now we can see here that the vectors are both pointing away from the angle, so we're able to use this 60 degrees here. So we've got the magnitude of A is 7, magnitude of B is 3, multiplied by cos 60. Cos 60, remember an exact value is a half. 7 times 3 times a half, which is 21 over 2. So just now it would be a good idea to take this example down in your notes before coming back for example 2. Welcome back, folks. So the second example, very similar to the first one, with a subtle difference here. So vectors A and B have magnitudes 7 and 3 units respectively and are at an angle of 60 degrees to each other as shown. What is the value of A dot B? So we know that A dot B, our formula is the magnitude of A multiplied by the magnitude of B multiplied by the cosine of the angle between the two vectors. But are the two vectors actually at an angle of 60 degrees to each other? Now, if you actually look at that diagram, vector A is pointing towards the angle and vector B is pointing away from the angle. So that's not very useful at the moment. So if we just extend vector A here, and we can now see that in this part of the diagram, that if we to use this angle here, which is 120, then both of the vectors are pointing away from the angle, which is what we need. They both need to be going in the same direction in relation to the angle, so either pointing towards or pointing away. So here we've got cos 120, and if we just have a wee look at our diagram here of the cosine graph, and we know that cos of 120 is an exact value, it's negative a half. So we've got 7 multiplied by 3 multiplied by negative a half, which gives us negative 21 over 2. So just now it would be a good idea to pause the video before the screen goes blank and take this example down in your notes before completing the assigned exercise for today.